Welcome to this video tutorial on the National Guidance for Plastic Pollution Hotspotting and Shaping Action. This is the 5th video, and we are gonna work on defining the hotspot selection. So we're at the end of this step-by-step approach in which we analyzed plastic waste generation, plastic waste management, production, import, export by polymer and by sector. And now that we have this complete picture of what's happening in terms of plastic in the country, then we can see how to select hotspots from in terms of plastic pollution. And what we mean here by hotspot is not, in this case, it's not going to be the geographical hotspot, so it's not region-wise, but is within the polymer, for example, within a dimension, like the polymer dimension, which polymers are the most critical in terms of pollution to the ocean. And these are what we define as hotspot, and similarly for the sectors. So as you can see, there is only one step that needs to be done here, and it's a manual step. And it will basically imply copying some data and finding, like inputting just demographic of the country. So we're gonna mainly work on tool T3.4, but the data are gonna be taken from tool T3.2. So let's go ahead and open the tool. This is tool T3.2 that we've worked on so far. And tool T3.4 is over there. And these, as you always, you find them online. And you can watch the first video if you want to see where to find the tools and how to download them, or just read through the tutorial. So the first thing that we need to do is fill in the cells in light blue background, so these ones. And in order to fill in these values, and you see is asking a lot of question of import, export by polymer, all down to improperly leaked, uncollected minus leaked, improperly minus leaked. And luckily, this is the same structure that we have in the polymer output sheet. So over here, you see we have exactly the same headers. So what you can do is that you can just select the entire table, you copy it, and then you go over here and you do paste special as values. So here is not going to do much because it was pre-filled with the existing values. Just because when we put the tool online, sometimes we pre-fill it with values, so you already have a feeling of how it's going to look like. But for the hotspot, for the sector hotspot, I'm gonna I'm gonna go ahead and delete the value that are here. And you see when I delete them, all the plots disappear. So then you go over there. Sorry, you go over there. I mean, you go to the sector output sheet in the tool T3.2. And here you see there is the table without fishing and with fishing. For this exercise, we're gonna take the table without fishing. So copy this, go over here, values. And then, yeah, you see, because there is no fishing, that there are some sectors that are empty, and you can just go over there in the bottom tables and delete this part if you don't like how it looks. Similarly, over there. And over here. And now hopefully they look good. Yes. Right, so let's see what we have. If we go in the Polymer Hotspot, maybe just to see what's going on, we have the same graphs as before, but now the sorting is different. And if you see here, the sorting is done so that you have the highest leaking polymer that is in red first, and then it's going in decreasing until you have other, and other, we put it all together at the end because it's a not better specified polymer. And sometimes, I mean, the graphs are created automatically, so sometimes you have to go in and fix it a bit before you put it in a presentation. But yeah, this first graph is just the mass balance, the material flow analysis that we've done so far. So you have production, and you can see, like in the case of Vietnam, production and import in the form of primary is quite big. And then you have import in products and export of primary products, import of waste. In light green is the recycling. Here we have the export of waste. This kind of petrol blue is the properly managed, properly disposed, is improperly disposed, and this is the uncollected. And then you can kind of have a look across and you see, I don't know, there is a lot of recycling LDPE and most of it is imported, for example. Or you can see PVC, there is quite a lot put on the market, but then most of it goes to increasing the stock. You can do all of this kind of consideration, but maybe, you know, there are a lot of things that can be said and a lot of analysis that can be done, but maybe if you want to look at only one metric to determine what's critical and what is not, that would be the leakage. So down here you have the ranking of the leakage by polymer, and maybe even better, you see like the total bar of waste generation and then the portion of it that is mismanaged by summing the uncollected and improperly disposed, and then some of it will leak to the ocean. And over here is just a zoom in on the leakage quantity, and the value, the share there is the leakage rate. So the share over here was the ratio between what was mismanaged and what was generated as waste. And this is what is called the mismanaged waste index. And here, what you have is the leakage rate. So is the ratio between what leaks and the waste generation. And there are kind of two ways that you can think about what matters in terms of priority when it comes to leakage. One is the polymer that are leaking the most, and another one is the polymer that are more subject to leaking. And in this case, it kind of goes hand in hand because you see like the highest leakage rate is 8% and is for LDPE, but also PET is around 8% and PET is the most leaking. So you could say like both LDPE and PET are critical, but then also PP has a high leakage rate. We developed like an automatic way of selecting the hotspot, and this combines information about absolute and relative leakage rates, so the height of the bar as well as the ratio, because the leakage rate really tells you, if you now put something on the market, what's the probability that this is going to leak into the environment. So it might be more interesting for a company or I don't know, even a private citizen to know, if I buy LDPE, you know, depending on the way that I manage it myself and it's the way it's managed afterwards, there is a higher chance for it going and leaking into the ocean. And similarly, like in the same way is done for the hotspot analysis, where you have these same 3 type of plots that you can have, and just sorry, just if I go back to the Polymer Hotspot sheet, at the very end, you also have these 3 plots. I mean, this is just for you for the presentation if you want to use them or not. The first one has all the mass balance plus the leakage. The second one doesn't have the leakage. And the third one is as the first one, but there are also the 1,000 tons written in it. And it's for all plastic. So it's not split by polymers, just really if you want to have an overview for the all plastic in the country. So normally in the reports by UNEP UCN that you can find on the website, it starts with this overview of the country where you have all of the plastic, and then it goes down into the detail. And finally, you see there is an application hotspot slide, but this one we left empty because it really depends. It's like really depends whether you want to do it or not. And in this case, in this tutorial, we haven't done it, so there is no value in it. And yeah, here is the automatic hotspot selection. So you see polymer, it tells you the most critical is PT and LDPE. And what it does is that it matches the top 3 by absolute leakage, and it finds the intersection with the top 3 by relative leakage. And the one that are both in the top 3 by absolute and relative are going to be in this red, and the other one are going to be just highlighted in this color. So here we tell you need to watch out for PT, LDPE, and then PP and PS are lower priority. And the packaging sector is highlighted as the main hotspot for the sector, and the other hotspot are kind of automotive, textile, agriculture, and the tires. But you see from the plot that really like the differences, there is a stark difference between packaging waste generation and packaging leakage and the rest of the leakage. And most of it is due to the fact that, in others like construction takes up quite a bit of the market, but most of it goes to additional stock. Finally, in 2B, you can find a little bit of overall recap, and the only thing that you need to do is to fill in the population data. So I'm just gonna go check whether these are already the data for Vietnam or not. So if I say population Vietnam, and then I look 2018, and I mean, you can use this source or other sources, but yeah, it says 95.54 million people. So that was indeed the population for Vietnam, and I guess the precise number, we took it from the World Bank. But if you're doing another country, you can go ahead and change the population number there. And there are 2 main outcomes. One is a bit of information. You see like what's the total plastic consumption, the per capita plastic consumption, and then not the consumption, but the waste. So consumption and net input are like the same. Waste is waste plus stock would be the consumption. And then the collection, the share of collected, the per capita collected waste, the recycling. So there is a list of useful variable that you can look at to communicate your result. And one that might be quite interesting is the leakage per capita, to compare your country to other countries. So in this case, in this example that we did, it would be 3 kilogram per capita per year of leakage. And then there is this table that shows you by polymer what is the difference in collection rate and recycling rate and all of that. And as you can see, we're focusing mainly on the domestic recycling. So in the case that we have done, there was quite a bit of recycling of LDPE, but it was of imported waste. So if you see, the recycling of domestic waste is only 5%. And that's it. I think that is all. So yeah, we've seen how to compute an analysis of waste pollution or plastic pollution in a country by polymer and by sector, and how to identify polymers and sector that are most critical, but mostly also quantify a lot of things like what's the plastic waste generation and how is it managed or mismanaged, and how much plastic pollution is there.